Hey everybody, welcome in that new Golaem tutorial which will show how you can control geometry and shading assignments based on simulation parameters. So I'm using here Golaem 9.2, and when you define your character definition, especially when you define the geometry part, as soon as you're going to weight something or you're going to add a shading attribute, we provide you the capacity to control it with a Golaem simulation attributes. So if I go here for that asset, for that character asset, for example, I realize that I have a weighting system here, which allows me to weight between two types of assets: the t-shirt asset, which is composed of multiple meshes, and the sweatshirt asset, which is composed of one mesh. And here I enabled weighting, and as soon as I'm enabling weighting, I have access to that weighting system that I can drive from here or from the rendering type panels if I want to create rendering types. And this is for the geometry assignments. And if you don't want to use random weighting, which is the one we're using by default, you can also specify that you want to use an attribute here, and you can provide the name of that attribute. And that attribute is actually a Golaem simulation attribute. When it comes to shading, here my t-shirt, for example, has a int shader. And once again, I can have either a random assignment, a weighted assignment, or I can use attributes control to not rely on a weighting system, but control it from the simulation. So here, for example, I can say, I'm going to have an ID, an attribute name, which will be called t-shirt ID, which will control the value of my integer texture index switcher. So those shading attributes, they are allowing to write some data which will be passed to the shading graph, and into that shading graph you can decide what you want that attribute for. So here this is an integer attribute, and it will be used for switching the actual texture of the t-shirt for the characters. So here I'm saying, okay, I'm gonna have a t-shirt ID simulation attribute that I want to drive from my simulation, and this is what's gonna drive that shading assignment there. So let me show you how does it work. When I'm in simulation mode here, I can add a simulation attribute. I can add it from two different ways. Either I can select the entity type, because this is an attribute which will be connected to an actual type in your crowd. And I can expand the Golaem simulation attribute here panel, and I can say that I want to add a new attribute. As soon as you create a new attribute, it will create a new node in the scene, connect that node to your entity type, and you can jump into this and see the various parameters. Another way, let me delete that one here. Another way to do it will be to go into the behavior editor, to right click on the entity type and say add new entity type attribute, and it will add it for you. And once again, you can either expand here and access the node from here, or you can jump from here and ask to switch to that node. Notice that simulation attributes such as this one can be shared amongst multiple entity types. Let's say you had multiple entity types here. You would be able to create a new entry and connect that entity type 1 into your other type if you wanted to. So let me dive into that node here. So we can provide it an attribute name. So here I'm going to say it's called t-shirt index. We're going to specify it's a Golaem simulation attribute, but we can also use vanilla old school PP attribute. We recommend not to use that one. That mode here is mostly for a legacy reason. And we can specify what type it has. So here I'll have exactly the same kind of input that the one that I had into my shader attribute, which is float, int, and vector. Because if we were diving into the character file, for example, we will notice that we'll have int, float, string, and vector, but string cannot be controlled with a simulation attribute because simulation attributes are only numbers. Great, so I'm going to specify it's a integer value. I know that I have 5 textures, so the value will range between 0 and 4. And if I want, I can have a initial value sampling. So here it's your range from the shader attribute is going to be onto that direction here. So this is 0, this is 4, this is all your entities, and those are going to be, the sampling for each entity for each value. So it's kind of giving you the probability that a value will be sorted. So here you're basically saying that all the values have the same chances to be scattered for your entities. If you were doing this, you would say that all the entities will end up with 4 value. If you were doing this, you will say that all the entities will have a 0 value being written into into the simulation attribute. And to make my point, let me show you how does it work. So here I've got my t-shirt ID, excellent, it's connected, it has a range between 0 and 4, and now I'm making sure that all of them will be 0. If I want this to be replicated into my graph, when I render, when I do export the simulation, I really want to think about exporting that simulation attribute. Simulation attributes can be used for a wide range of things, storing values for simulation, so we don't always know that they're going to use for shading. So if we know they're going to be used for shading or for anything or for geometry assignment, let's say, you will have to say it, and you will have to just select that t-shirt ID, add it into the list, so when you export the cache, now all the entities will know about this. And if I press render, now I'll have all the characters wearing a t-shirt being assigned with that, 0 value. Let's say we want to maybe make a point about there are 4 different texture values here, and I want to range equally between all the values. I can change that value here, but let's not forget to export the cache because this is a simulation-based data. So we want to rerun the simulation to run the cache, and I'm going to store the snapshot, and we want to update the scene. So now you can see that the characters are not having 4 different colors for t-shirts. So here black, the bicolor asset here, some turquoise and some blue, and now we're ranging through those values there. And I can once again store a snapshot. So that was before, that's after, because we've been controlling. So here this is sampling the initial value. This is the way to do a repetition, but you can also use some behaviors to write that value if you want to. So first thing first is when you're in simulation, how can you check the value of those without having to go for render? You can use the attribute spreadsheet node tool, and the attribute spreadsheet tool will show you for each entity you have in your scene the value of t-shirt ID, and we'll let you know exactly what it is. If it's connected to your shader, you also see that within the viewport we are able to read this, connect that, and make sure that we draw the right property into the viewport. So here, for example, we know that this is entity 30,001, so 30,001. It's here, so we know that it will have value of 2. T-shirt ID will be value of 2. Okay. Let me show you now maybe how we can control that value using a channel operator. So let's say if my characters are in a specific zone, I would like them to have a specific value, but if they're not, I would have them to have another default value. So what I'll do is I'll go back to my attribute control type here. Sorry, I'm gonna go back to my type, and I'm gonna say either from the sample initial value here, I can say that, okay, I want everybody to be 0 there. So if I change that ramp here, everybody will be 0. Another way I can do it is just by giving a random min and max a specific value if you want to. So here I'm saying all the characters will have a t-shirt ID of 0. So I don't know which one is 0. It's probably black or something. But if they're in the zone, I want them to be maybe 4. So I'm gonna draw a zone here. That zone will be, let's say there, and let's cross the entity so we can actually see it into the viewport. And what I can do is I can go into the behavior editor, and I'll be able to create a channel operator node. And into the channel operator node is a behavior that we can use to do some advanced actions. Like let's say there's no behavior specifically to write an attribute, so the channel operator is the multi-purpose behavior where you can actually draw simple or complex graphs to do actions. So what I'll do is I'm gonna say, okay, that behavior will be triggered only when I'm in a zone. I'm gonna select the start trigger, I'm gonna open it, I'm gonna say that behavior only starts when you're in a zone, so I'm gonna change the default trigger to specify that this is gonna be a zone. I'm connecting my zone to my trigger. And now that behavior only runs for those characters. If I check that character, we can see it's running the channel operator behavior. If I check that character, it's not running anything, which is expected. And I'm gonna say that channel operator behavior is doing a simple action, which is writing into a Golaem attribute a value of 4. So I'm gonna say I want to write into a Golaem attribute. I've got, of course, plenty of options, but this is default mode. The attribute is my t-shirt ID, that's great. And I'm going to use a entry node, which is really simple here. I'm going to say my node here is a float value, and I'll just, write 4 for reduced characters there. So what it says is when those characters are in the zone, 4 will be written into the output, so into t-shirt ID, and this is fully dynamic, so it will not replicate properly into the viewport. But if I check attribute spreadsheet, I'll probably find a value of 0 everywhere, except a couple of 4 here and there, which are based on the value of the location of the zone. And now I can export that simulation, render, and where's my render view? I guess this is here. Oh, it's rendering, but it's not updating. Let's let finish the image. Here we go. So now you can notice that all the characters which are wearing a t-shirt, the sweatshirt is not affected because it has a different assignment, of course, in terms of shading, so it does not depend on that attribute. You can see that everybody else is wearing that blue t-shirt except the characters which are within the zone. So here we control the shading assignment attribute based on simulation attributes. And this is something that we can do for, assets as well. I was referring to the fact that this is for shaders and geometry, because I was saying that when you have a weighting system, you can specify here if you want it to be controlled by weight or by an attribute. So this is exactly the same workflow here. So for example, I can probably say that if I provide another attribute here, let me show you. Let's create another one, which we'll call geoassign here, which will be of type integer once again, because we want to pick a branch. We're going to specify it as a value between 0 and 1, and maybe we can just specify 0 for now. I want to make sure that I do export this into my cache. Okay, I want to make sure that I'm controlling my weighting here based on that attribute here. I'm going to save that. Don't forget to save that file because it will be evaluated at render time. Now I can export my geometry, and if we check now, we can see that all the characters are wearing the t-shirt because we provide them with a value of 0. If I was providing them value between 0 and 1, we'll have, once again, sweatshirts and t-shirts scattered all around. And once again, you can control that attribute the way you want to. So this is also a way to control your geometry assignment if you want to based on those attributes. Takeaway is, once you create those, let's not forget to export them into the cache so they exist and they can be read from your simulation cache. If it's not read, you'll probably have, let's remove this for a second and let's do some render. You probably have some messages, warning messages, or you should, if you don't have any, which should tell you that that attribute doesn't exist and it can't be read from the cache. So I hope that helps, and see you into the next tutorial.